Okay, welcome to lesson 2 of linear relations unit 5. So we're going to talk about what the heck is a linear relation. So we're going to look at both words and we're going to figure out what are all of these things describing. So if I look at just the left-hand side and I look at the word linear, okay, the word linear itself, when I look at that word, it's talking about a straight line. Well, we talked about in unit 1, if it's a straight line, it is a single dimension. It's one-dimensional. Okay, it's a single dimension. We're measuring length. Okay. What else is a line? Well, a line is the distance between 2 points. That's what a line is. And linear points are objects that follow the path of a straight line. Okay? So they create a straight line. So that's what linear means. Anything that creates a straight line. And then we look at the next definition. Relation. Well, a relation just means that they have something in common. That they have some sort of a relationship to each other. For example, as we get older, as we age, we sometimes, our height will get, as we get older, we get taller. And then it levels off once we hit our maximum height, okay? And then it's going to start to slope down when we start getting really old, we start to shrink again, right? That's just a little bit, we start to shrink.
Were you taller at one point?
At one point, yeah, I was taller at one point.
How tall are you at the one point now? How tall are you now?
I don't know how tall I am right now.
Tallest you've been.
5'4". No.
5'4".
Okay. Wages versus hours. That's another very common one. So, however much time you work, you get paid more. So, for example, if I work 2 hours, I'm going to get paid double my hourly wage. If I work 3 hours, I'm going to get paid 3 times my hourly wage. If I work 10 hours, I'm going to get 10 times my hourly wage. Distance and time. Us driving to Red Deer, same thing. Distance and time, they have a relationship. Connections between a set of numbers. So if I wanted to say to you, we're at point A is Silver Lake, point B is Red Deer, and maybe there's 20 kilometers in between. So we've got a connection between a set of numbers and a set of points. Okay? So that's what we're talking about. The other thing we talk about a relationship is to use one number to find information about another number. So this is where we try to do what's called interpolate or extrapolate. We try and find information that's already in the graph information that they give us, or we find information when we extend the graph. And that's where that's talking about. So let's take a look and go back to our basic graphing skills. Let's take a look at a Cartesian plane. Well, what is a Cartesian plane? A Cartesian plane is a grid that is cut into 4 squares. So we've got a grid cut into 4 squares here. So we're going to go counterclockwise. We have quadrant 1. We have quadrant 2 going left. Quadrant 3 on the bottom left. And again, quadrant 4 is on the right. So we're going counterclockwise when we measure them. We're going around the circle counterclockwise. And where do we always start? We start at our positive arm. This is called our positive arm. Why do you think it's called a positive arm?
It's on the right.
It's on the right of those x numbers. It's on the right-hand side of 0. So those x numbers are all positive. So basically what a big Cartesian plane is they've taken 2 number lines and they put them together. So what they've done is they've taken a number line that goes straight up and down on the y-axis here. That's a number line. They've just got it vertical. Then they've got our number line going left and right. Okay, that's our Cartesian plane when it cuts into 4 quadrants. All right, what do we call the center? It's got a special name. It's spot letter E. It's got a very, very special name.
Is it
It is the origin. So we're matching. On the bottom right, we're going to write letter E. That is the origin. Okay? Now, whenever we write a point, it is written, and I'm going to write the point for the origin, it is 0, 0. Now, when we write coordinate points, we always write coordinate points as an X number, then a Y number, just like we would alphabetically. So it is X, then Y. So I'm going to give you a couple minutes. What I want you to do is I want you to go around and I want you to find all of the other numbers. So the coordinate locations are on the right-hand side. So right here that I'm going to circle in green, this is called your location map. Those are the locations. You have to match which letter is that location. Okay? So push pause now and play when you're ready. One more little quick hint. When we write our coordinates, we have to remember, yes, it's an X, Y number, but we also have to remember where are all the quadrants. Well, if this is 0, 0, letter E right in the middle, if I go left of that, these are my negative X numbers. -1, -2, -3, -9, okay? If I go down from there, those are my negative Y numbers. So let's take a look at the quadrants. In quadrant 1 will always be a positive and a positive. Quadrant 2 is going to have a negative X, but a positive Y. Quadrant 3 is going to have a negative X and a negative Y. And quadrant 4 is going to have a positive X, but a negative Y. Okay, so those are the way the quadrants work with their signs. So the first one's always X. So this guy here has a negative X number. These guys have negative X and negative Y. Over here, just negative Y. All the positives, same thing. Positive X, positive Y. Positive Y number. Positive X number. So that's how you can help match. Okay, continue matching. Okay, you've had a couple minutes. Let's make sure you've got them right. You have B, H, F, I, G, C, A, D, and then we all match E.
No, I got all of those correct.
Oh my god, you're super simple.
Okay, moving on. We want to talk about continuous versus discrete data. Continuous data is data that never ends. It's got data in between each point. So it's data that will continue infinitely in both ways. So age. So can I say that you are 1 day old? Can I say that you are 14 years, 7 days, 3 months, 2 hours?
Yeah.
Yes, we can.
Yeah.
We can put our age right to the nearest second if we have to. So that is continuous time. Time is typically always continuous, okay? So, sliding down a hill on a sled, on skis, or a snowboard, 100-meter sprint, how you grow over time, all of those are continuous data. However, if we take a look at discrete data,
What is time not continuous?
I'll give you an example right now. So, time will be continuous unless they're talking about specific things with money. So, for example, if I say I want to deposit $50 every month, well, time isn't continuous there. I would not join the points because I'm not doing it every day of every hour. If I were to graph that, I would just be graphing single dots, one for every month. And it would be $50, $50, $50. It's increasing every month. Okay? So I would not join those points. The ones that you join are for continuous data. All the time you can join them. But if it is discrete data, you are not allowed to join the points. And the reason we're not allowed is for the reason I just gave you. There's no data in between the points. So for example, I'm not going to be putting money in the bank every hour, every second, every day. It's once a month. Okay? So that's why sometimes time will be a discrete factor. So not all of your data is going to always just be a straight line where you connect all the dots. There are times when we won't connect the dots.
Yes.
Okay, so shoe size. It's another example. Can I tell you, or can you buy a pair of shoes that is 6 3/4? No. Can you buy a pair of shoes that is 7.9? No. You buy shoe sizes according to full sizes or half sizes. So again, that would be discrete data. Okay? All right, let's take a look at variables that would be. For example, if I'm going to do a sprint, if I'm sprinting, would I consider the time there discrete or continuous? Continuous, good. So this guy is a continuous. Shoe size, we just talked about it. What would it be? Discrete, good. The number of kids who pass Math 9, or 10C it says here, what would that be? Discrete, because you can't have 0.2 of a kid. Unless I chop your arm off, maybe. Height of students. Continuous, good. All right. If we take a look at the next example, it's about toothpicks. So here's my example of toothpicks. So in this case, in the first lesson, we took a look at examples that had tables of values that were vertical. This one is a horizontal table of values. When we have horizontal table of values, X is always the top, Y is always the bottom. It always goes that way. And again, the reason it's alphabetical. So X is on top, Y is on the bottom. So we're talking about the number of triangles that the number of toothpicks can create. So one toothpick creates no triangles. One triangle is created by how many toothpicks?
3.
3. Well, how many toothpicks did I have to add to my first one to make a triangle?
2.
I had to add 2. Well, how many more am I going to add to make the second one?
2.
2. And what about the third?
2.
Good. So we're going to be adding 2 every time. Well, if you take a look, what do you notice the pattern on the bottom is?
+2.
+2. Okay. So the number we find on a horizontal table of values, the number we find from the bottom is going to divide by the number we find on top. What are the numbers we're adding on top? They're adding by 1. So we're taking 2 divided by 1 is 2. So now we've found the pattern. Okay, there's our pattern. So this number, the pattern number we find, has to sit in front of the x variable. And our x variable in this case is t for toothpicks. So that means our equation starts with 2 with a t, 2 toothpicks. So we know that much so far. And remember, what do we always state? We always say that we have plus or minus something equals the other number. So equals my y number, which is p for toothpicks this time. So we now pick a test point. We're going to pick a p number and a t number, and we're going to substitute them in for t and p. And then we're going to check to see if the left side equals the right side. And that's how we use our test points. So I'm just going to use the very first test point here that is outlined in red, the 1 and the 3. So the 1 is going to be a t number. So I'm going to go 2 times my 1, the t number, plus or subtract something, equals, what's the p number that matched the 1? 3. Good, it's got to equal 3. All right, now we do the bed mass. 2 times 1 is how big? 2. 2 plus or subtract something gives me 3.
1. Plus 1.
Plus 1, okay? So we're finding our pattern, and now we know that we have a 1 we have to put in there, and we can scribble out the subtract sign. It's not subtracting 1. It is plusing 1. So we scribble out that subtract sign. Now we got to test one more point, just to make sure it works. So 2 times a number plus 1 equals. All right, let's find our next test point. 3 and 7, okay. 3 for x, 7 for y. All right. So what's 2 times 3? 6. Does 6 plus 1 give me 7? Yes, the left side equals the right side. So that means that my equation is correct. Okay? Now we're going to graph the equation. Oh boy. Now we're going to check and see. These are toothpicks. Am I able to make a triangle with one toothpick?
No.
With two toothpicks?
No.
No, we need minimum 3 toothpicks.
Well, that's not true. If you're doing it
No.
on the edge of a surface, you can.
Well, if you break it, yes. Okay, so on the bottom, here is 0. We need to label our axes. So this is X, so we have T for toothpicks down below. And our vertical axis is P for, oh, sorry. It's P for toothpicks, and T is for triangles. There we go. Triangles. P is toothpicks. So juice. Alright. P is toothpicks vertically. T is triangles. Now we're going to put our numbers. So we've got 1, 2, 3, 4, 5, and 6. Going up, same thing. We're going to count up to 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is right there. All right. So now we plot each point. So one triangle is made from 3 toothpicks. 2 triangles is made from 5 toothpicks. 3 triangles is made from 7 toothpicks. What do you notice the points are doing?
Going up by 2.
They're going up by 2, but look at what I'm going to do. I'm going to go 1 right, 2 up. 1 right, 2 up. So what do you think the next one is?
1 right, 2 up.
1 right, 2 up. 1 right, 2 up. Okay, that's our slope. It is so. Okay. Now, remember, am I going to join those dots I just created? No, because we can't make half a triangle, we can't use half a toothpick. Okay, so that's discrete data. We will not join the points. Okay? What this part right here is, this is not me joining the points, this is me showing you how far it's moving. It's moving 1 right, 2 up. I'm just showing you how far it's moving. That's what that is. And it'll always use the same pattern. Okay? Now, I want you to follow, and everybody take a look at my pattern I found up here. Everybody look right here. What number did I have right there?
2 over 1.
2 over 1. Well, let's see on my pattern here. What did I do? I did 1 to the right and 2 up. That's where we get our patterns from our slope here. So when we find that number 2, that actually told us 1 right, 2 up. All right, we're going to take a look at another couple examples. We can represent relations in many different ways. So, we can use words, we could use graphs, we can use a table, and we can use an equation. We just saw examples where we had a situation describing words, we had a table of values where we had to create an equation, then we had to graph our equation. So, we have multiple things we have to do for each equation. Now, the graph of our relation is considered to be a straight line. So let's fill in the blanks, please. That is a straight line. And if it is a straight line, we have a linear relation. Anything that makes a straight line will create a linear relation. And the reason is because a constant change in one quantity, so in one value, produces a constant change in the other quantity. Okay? So it forms a straight line, and in a linear relation, any constant change in one quantity will make a constant change in the related quantity. So when x changes, y will change. X is known as the bossy one. Y will change according to what X tells it to do. Okay? That's why we always create our equations in terms of X, because X is the boss. Okay? All right, we're going to take a look at the example on the bottom of your page. It says, a local phone company offers a cell phone plan that has a fixed cost per month. The cost is related to the number of text messages sent. So the fixed cost is $20 and the average text message is 10 cents. So what we're going to do is we're going to represent it as many different ways as we can. Well, let's try to do it in terms of a table of values. So we can do an equation, we can do a table of values. So for 0 text messages, so number of messages, and this is cost. So for no text messages, it's going to cost you $20.
Oh shoot.
For 1 text message, it's going to cost you $20.10. For 2 text messages, it's going to cost you $20.20. You add 10 cents every time.
Why? Like that's $20.
Because they're giving us a fixed cost of $20 in this question. So our fixed cost is always with 0.
That's why it's just.
So that's one way we can relate it. We can also relate it going by an equation. So if we said our fixed cost is $20, we have to add 10 cents. How do I write 10 cents in terms of dollars?
0.1.
0.10. Yeah. It's got to have a 0 in the front. So 0, whoa. That's pretty. 0.10. Now, he's the number of messages, so we would say M for messages. So $20 plus 10 cents a message. Now, if you wanted to write it in terms of cents, I could take this now, because that's $20, 20.00. I could say that's 2,000 cents plus 10 cents per message. So you could write it in terms of dollars, or you could write it in terms of cents. So there's 2 ways you can write the equation. The one that we always use, we use the dollars and cents one. We never use the one that's only in cents. Okay? We use the proper money. Is there any other ways we could have related this? How about a graph? I could have my fixed cost of $20, and then it would go up 10 cents every time. Now, am I going to join the points on those? Would this be discrete data, or would this be continuous data? What do you think? It is discrete. Well, it's not just discrete because it's money, but it's discrete because of the message. Can you send half of a message without hitting the send button?
Yeah.
You can't. Because you actually have to hit the send button to send a message. So you can't send half of a message. Okay? Does that make sense? Now, I don't mean if you want to send someone hi there, you don't send hi first and there second. That's not what I mean by half of a message. By sending 0.5 of a message is impossible. You either send it or you don't send it. Right? It's one or the other. Okay. Let's now deal with a table of values from an equation. Table of values from an equation. Okay. So, if I take a look at the equation, the first thing I do is I find the one with the letter x. And x is the independent variable. It's the input and independence. Okay? So like I said, he's the one that bosses the y around. He makes all the decisions. Y is considered the dependent variable. He depends on what x tells him to do. Okay, so x is the bossy one. Now, if I want to write a set of coordinate points, all I need to do is I usually start with 2 negative values and then 2 positive values. So it's good to get into a habit of going from -2 to +2. So -2, -1, 0, 1, and 2. So it's a good idea to go from negatives to positives. Now they must go in order, okay, always. Now we're going to try and find the answers. How can we tell if it's linear? Well, first of all, we have to see if it's a constant rate of change. So we are going to write this 5 times so we can find the answers. So what we're going to do is this. 2 times the number, subtract 4 equals. 2 times the number, subtract 4 equals. We're going to write that 5 times, everybody. Okay, so we're going to substitute a number in the brackets. And that's going to tell us the other number. Whoops. Okay, so let's write that 5 times, please. And then we're going to substitute in all those x numbers that we put. Okay, so we're going to put every number we see here on the x list in our brackets. So -2 goes in, -1, 0, +1, and +2. Now we're going to solve each of those. We're going to do BEDMAS. So when we solve these, we're going to get 2 times -2, subtract 4 is -8. And again, all you have to do is put these in your calculator. Let's try our mental math though. BEDMAS, multiplying is going to go first. 2 times -1, -2, subtract 4 more, -6. 2 times 0, 0. 0 times anything is 0. Subtract 4 is -4. What do you think the next one's going to be? -2. And what do you think the last one's going to be? 0. What do you notice they're going by?
-2.
They're adding 2 every time. They're adding 2 because they're getting bigger. The numbers are getting bigger. So if the numbers get bigger, they're adding every time. They're adding 2 every time. Okay? Now, what is the pattern on this scale here, on the x scale? What are they adding every time on the x? They're adding 1. Well, we found the scale on the right is 2. The scale on the left is adding 1. What's 2 divided by 1? 2. So our pattern is 2 over 1. Now, are they going up by a constant rate of change? Does it stay going up, adding or subtracting by the same amount? Does it add the same amount every time? Yes. If it adds the same amount every time, or if it subtracts the same amount every time, it is considered a constant change. So yes, this is linear. And it's because there is a constant rate of change in the y values. So we're going to put B/C because there is a constant rate of change in the y list. So in that y list, it's going up by the same amount every time. Okay, so make sure you've got that written down. Push pause now and play when you're ready. Okay, referring back to this pattern, where did I get the 2 and where did I get that 1? Well, the 2 and the 1 came from the y numbers and the x numbers. So these are called on top, that is the y list. That's the pattern we get from our y list. And on the bottom is the pattern we have for our x list. And once we have both those patterns, that's when we divide. And now our full pattern would be a 2. Now that pattern we're going to start to learn. This pattern is actually called our slope. And it shows us how to move the dot when we're actually graphing. It shows us how to create the next dot that goes on the graph. So that we can join our points and draw a line. So let's take a look at the next few. The first one, we want to see what is the pattern? How do I know what the pattern is going to be? So first of all, what we're going to do is we're going to check the X pattern. What is the X pattern doing on each one? That's what we want to do, is check your X pattern first. So, we're adding one, adding one, adding one. Over here, adding one, adding one, adding one. Over here, add two, add one. Oh boy. The third one is a little tricky. We're going to have to deal with that guy a little bit trickier. So, on the first two, we have an even constant change on the X values. Now we need to find out what the Y values are doing. So what happened to 7 to become a 3? It subtracted 4. Good. So we subtracted 4 here. So we're going to subtract 4 again. We're going to get -1. And then we're going to subtract 4 again. And we're going to get -5. Okay? So the numbers in our pattern we get over here is -4. We're subtracting 4. So the pattern for the first one is going to be -4 over 1. There's our pattern for the first one. Now we need the pattern for the second one. But look at what we've got. We've got numbers in between. We're missing spaces. So we're missing a number, then we have a 7, then we're missing a number, and then we have a 10. So what we have to do is we have to figure out how many spaces are actually between the 7 and the 10. To get from 7 to 8, 8 to 9, 9 to 10. There's actually 3 spaces in there. So, what would I have to do? What are they adding for each time if there's 3 spaces?
Oh,
But I've only got 2 steps to get there.
3.
What are you going to do?
So I think it's they're adding. Oh. No. Damn it.
1.5, exactly. They're adding 1.5 every time. So if this guy, if I put 8.5 there, and I add another 1.5, will I get 10?
Yep.
I sure will. So what happens is this, you guys. So we find that the difference between 10 and 7 is 3.
But
And we have to divide it. We have to divide it by 2. And 3 divided by 2 gives us our 1.5.
so
And
number
why are we dividing it by 2? Because that's the number of steps on my chart that there are away. For example, if I follow my green, I'm going 1 step, 2 steps. So from my 7 to my 10 on my chart, I'm only got 2 steps. That's why I divided by the 2. If there was 3 steps in between them, I would divide by 3.
so what would be number one?
Okay? So now we're going to work backwards. Now we're going to take 7 and subtract 1.5. So what should that number be?
5.
Perfect. That number should be 5.5. It just is and with an and sign. Now this one here, we're noticing right away that they added 3. Okay? They added 3. But if I want to find the next number, look at what the pattern's doing for between the first 2. What's my pattern? It's adding 2. So if it's adding 3 and then adding 2 on the left, I need to remember our pattern needs to be put into a fraction. So this guy's pattern for the first 2 is 3 over 2. And what's 3 over 2? 1.5. So that means for every 1 step, they're doing 1.5. Because here they've gone 2 steps. From 0 to 2 is 2 steps. They've gone 2 steps, but they've added 3. Now here we're going to go 2 steps. We're going to add another 3. What are we going to get? -4. But now we're not going 2 steps. Between 4 and 5 is only a difference of 1. So instead of adding 3, I'm not going to add 3 anymore. I'm going to cut it in half. And I'm going to add 1.5. So here I'm going to get -2.5. Because you have to add 1.5 to -4. Okay? So this guy we're going to add 1.5. Now, who can tell me in their own words, why did we add 1.5 on this step to get to this step? So from step 3 to step 4, whereas we added 3 in step 1 and step 2.
It's a pattern.
It's going off.
That's what it's supposed to.
Exactly. So if you look in the first 2 steps, there's a difference of 2. So that means every 2 spaces they would jump 3. Well, if I'm only jumping 1 space, I have to cut the 3 in half because you cut the 2 in half. From 2, you're going 1 space instead of 2. All right, let's take a look at another table of values. We have 0 numbers in our table of values. So again, what we're going to start with this time is we only have 3 spots. So x is always first, then y. Then we need a negative number and then a positive number. So I need -1, 0, and 1. -1, 0, and 1.
Why do you put -1?
Remember, we always want to put 1 negative value at least, right? Depending on, we want to have an equal number of numbers over here and here if possible.
You just put random numbers.
No, we're not putting random numbers. We're trying to put 0 in the middle. So I would take this guy being 0 right here in the middle, and then I would go +1 or -1 on either side. Okay? All right, so now what I'm going to do is I'm going to write this guy 3 times. So 6 subtract 3 times a number. 6 subtract 3 times a number. And then 6 subtract 3 times a number again. And all of these are going to give us the answer to what's filling in our y box. So we know how far the y goes. So now, if I put my numbers in, -1, 0, and 1, we now have to do the BEDMAS. So the multiplying goes first. So we're going to multiply here. A negative times a negative is a positive. So that's 6 plus 3 is positive 9, because this is going to be 6 plus 3, because negative times a negative, remember, is positive. What's 0 times anything? 0. So really, just wipe it off. The answer is 6. What did they add from 9 to 6? Or subtract, I should say.
3.
They subtracted 3. So what do you think my next number is?
3.
3. Well, let's figure it out algebraically. If I have 6 subtract 3 times 1, that's 6 subtract 3. That gives me 3. Okay? Now we're going to plot our points. Now, whenever we've got a graph, most of the graphs I've given you go from -10 to +10, -10 down below to +10 above. This is called our Z standard window. Okay? That's called Z standard. All that means is that you're going from -10 to +10 on both axes. Okay? That's all it means. -10 to +10. Okay? That's what it's telling you. Then we're actually going to plot our points. Now, when we plot them, we start with the x values. If I were going to use this first point, -1 and 9, what it's telling you is to start at 0. I start at 0, 0. It's telling me to go left 1, up 9. And that's where I make my dots. Okay, left 1, up 9. The next one says, starting in the center, I don't go left to right, I just go up 6. So I go up 6 and make a dot. Well, what do you notice, guys? Watch carefully. Look at my pattern. Go 1 right, how many down? 3 down. 1 right, 3 down. 1 right, 3 down.
Now we're at 0.
Now, did the question give us a problem-solving situation where we don't know if we can join the dots? No, it didn't tell us if we're discrete or continuous data. So if it doesn't tell us, we always join the line. So we join the points and we create our line. Now remember, it's continuous in both directions, so please put an arrow on both ends, because that means it continues in both directions. Okay? Now, if we take a look at our equation, I want everybody to look up at the equation, to look up at the number 3. What kind of 3 is in front of the x? What kind of 3 is in front of that x, you guys?
What kind of 3?
It's a -3. And if I were to make that into a fraction, it'd be 3 over 1. Now everybody look and see how I moved my dot. I moved my dot 1 to the right, and then what did I do? 3 down. Well, look at where I'm getting those numbers, you guys. from the equation, the bottom number under x, if there is no number, is always a 1. And that number will always move your dot to the right. That's why with fractions in the last couple lessons, in the last couple units, we always said fractions will float to the top. They have to on purpose, especially if we're graphing, because that bottom number can only ever move to the right. And if you don't see a bottom number, you put it over 1 and create a fraction. So that shows us how to move our dot. So we've got 1 to the right, and then the -3 here means 3 down. So I moved it 1 right, 3 down. So our equation actually has our pattern. And guess what you think that number 6 is? Is considered what we call the start point. So the number without the variable is what we call the start point. So I would have started right there at 0, 6, and I would have continued my diagram here going 1 right, 3 down, make a dot, 1 right, 3 down, make a dot, 1 right, 3 down. And that's how you would continue that line, okay, with the pattern. Okay, we're going to get that into that more often here. All right, let's take a look at the next 2 examples. So did we see patterns in the graph? Yes, we did. So it had the same slope. 1 right, 3 down. Okay, it had the same slope. You might want to call it a pattern, the same pattern or slope. Okay, 1 right, 3 down. Is it linear? Yes, because the points formed a straight line. So we have one last example, and it's going to be graph. So we start the example on the bottom of your page, and we're going to finish it on the top of the next page. And all this example is it's about holding a dance. And every time the grad committee holds a dance, they have to talk about this stuff. They have to say, okay, we need to make a profit. We have to have the cost of the DJ, the cost of the music, the cost of everything. And then they create your price. So these guys are getting a really cheap DJ for $200. So that's always your base cost. And it says the profit in dollars is 4 times the number of students who attend, minus the 200. So we're talking about a profit one. So if we do a profit is going to be 4 times the number of students, $4 times the number of students, subtract $200. Okay? Because $200 is the base price. So we're going to create an XY value here. And we're going to do it this way. So we've got X and Y, and in this case, X is going to be S for number of students, and Y is going to be P for the profit, for the money. Okay? So, if I want to create a relation for this, what I'm going to do is I'm going to put, if X is the number of students, what if nobody comes? What do I have to pay?
Well, $200.
What if 50 people come? What do I have to pay? What if 100 people come? What do I have to pay? And then we're also going to do it for 2 more rows. We're going to go from 200, and then we're going to go 300. Okay? So it's not going to go up by the same amount. We're going to have to graph it. So if we take a look, we want to create the equation. We already created our equation. So our profit is 4 times the number of students minus $200. So if I say each square going up and down is equal to 50. So each square going up and down is equal to 50. So that means this is negative 50, negative 100. I need to find negative 200 because that's our starting point.
The numbers on the X was 0, 50, 100.
And then 200. And 300. We add another one. So if we say we're going up by 50s for each one, for each square, then that means this guy's 100, 200, 300. Okay? And here, we're going to say 2 squares. Okay? So every 2 squares left and right is going to be 50. Okay? So every 2 squares left and right is going to be 50. So I got 50 there. There's 100. 150. 200. 250. 300. Try to make sure you have your legends correct. I'll give you a minute to write that down. Push pause now and play when you're ready. Okay. So now we're going to plot each of them. Okay? So, at 0 money, at 0 people attending, where was I? Well, we're not sure. So we have to write this down. We're going to go 4 times the number, subtract 200. 4 times the number, subtract 200. 4 times the number and subtract 200. Now the numbers we're multiplying by, remember, are the numbers we put in our table of values. And the numbers we put in our table of values were 0, 50, 100, and we had 200 and 300 as well. Okay, so let's try and solve those. Okay, I'll give you a minute to do that. Push pause now and play when you're ready.
Oh, you weren't. Aw.
Okay, so now we're going to plot the points. We find that 0 is negative 200. That means if nobody comes, I'm out the money for the DJ. It costs me $200. That's what this negative point is down there. Now, if 50 people come, okay, if 50 people come, I'm right on the line. If I'm right on the line, that means I'm making no money.
But you made a good guess.
Okay? Now, if 100 people come, I make $200. So, now I have a number up there. And if I've got 200 people that come, I end up at 600, way up there. So what are we noticing? Will I join these dots to create a line? No, because this is discrete data. However, how many students do I have to have come in order to make a profit? Well, let's take a look. Right here is called my break-even money. That's called break-even. If you're on that line, that means you make your money back. I need to be above that. So for me to make my money back, I need to have 50 people come. So for me to make a profit, how many people actually have to come?
51.
51 people. Just one more person has to come.
Oh.
So if 50 people come, I make the money to pay the DJ. And then any more money, any more people over 50 is all profit. So that means that 51 people I need. I need 51 minimum in order to make a profit. Okay? Because your X line here is your break even. And break even just means you make your money back, but you don't make any profits. Okay? You are now going to finish in your practice booklet all of lesson 2. This now concludes lesson 5.2.